Hi everyone, and welcome to our channel where we make complex topics simple. Have you ever wondered how a streaming service seems to know exactly what movie you all want to watch next? Or how a system can identify a handwritten digit? Often the magic behind these features is a surprisingly intuitive algorithm. Today, we're diving into one of the most straightforward yet powerful algorithms in machine learning, K-nearest neighbors, or KNN. It's a fantastic starting point for anyone new to the field, because it is based on a concept we all understand from everyday life. At its heart, the K-nearest neighbors algorithm operates on a very simple premise, best summed up by the old saying, "Birds of a feather flock together." In machine learning terms, this means we can predict the category of a new, unknown piece of data by looking at the data points that are most similar to it. Essentially, an object is classified based on the company it keeps. If you're surrounded by a certain group, it's highly likely that you share characteristics with that group. KNN applies this exact logic to data, making it a powerful tool for classification tasks without needing a complex model building phase. It's all about proximity and similarity. Let's visualize this to make it crystal clear. Imagine a graph with two distinct groups of data. We have Category A, represented by a cluster of blue dots, and Category B, represented by a cluster of red dots. These are our known data points. We already know which category each one belongs to. Now a new piece of data appears on our graph. We'll call it our unknown data point and color it green. Our goal is to figure out whether this green dot should be classified as a blue Category A or a red Category B. It's sitting somewhere between the two groups, so how do we decide? This is where the K in KNN comes into play. K is a number that we, the developers, choose. It represents the number of nearest neighbors we will consider when making our decision. Let's say we set K to 5. The algorithm will then identify the 5 closest data points to our green dot, regardless of their color. On our graph, we can imagine drawing a circle around the green dot that expands just enough to enclose its 5 nearest neighbors. Looking inside this circle, we might find that it has captured 3 red dots from Category B and 2 blue dots from Category A. These 5 points are now our key influencers. With the neighbors identified, the final step is simple. We let them vote. Each of the K neighbors gets 1 vote for its category. In our example with Cabre 5, we have 3 votes for Category B, the red dots, and 2 votes for Category A, the blue dots. The category with the most votes wins. Since Category B has the majority with 3 votes, the KNN algorithm predicts that our unknown green dot belongs to Category B. On our animation, you'll see the green dot change its color to red, officially joining the majority class of its local neighborhood. It's as democratic as that. So to recap, the K-nearest neighbors algorithm classifies new data by looking at the most similar data points in an existing data set and taking a majority vote. Despite its simplicity, KNN is incredibly useful in the real world. It's a key component in recommendation engines that suggest products or movies based on what similar users like. It's also used in image recognition, financial analysis, and even agricultural science to classify different types of crops. It is a foundational, instance-based learning algorithm that proves that sometimes The most intuitive solution is also a highly effective one. Thank you so much for joining us today as we explored the K-nearest neighbors algorithm. We hope this explanation has helped you grasp the core concepts behind this elegant machine learning tool. If you found this video helpful, please give it a thumbs up, and don't forget to subscribe for more deep dives into the world of technology and data. We'll see you in the next one.